Hello everyone, today I will show you how to solve quadratic equation by completing the square. We have a quadratic equation here, and I will also transform this standard formula to vertex formula, and I will show you how we can quickly transform standard formula into vertex formula by completing the square. So there's a shortcut we can apply, but first let's solve it by completing the square. So while completing the square, we need to move this constant. This is a b c constant. C has to be moved to the right side, so let's move it and continue. Okay, x squared plus 6x equals 7, because after we move the term to the right side we need to change the polarity, change the sign from negative to positive or from positive to negative. So here we have negative, so we change it to positive. The next we need, next we need to get this middle term. We need to divide it by 2 and take it to the power of 2. So it will be 3. 6 divided by 2 is in brackets, so we have to do it first. 3 divided by 2 is 3, so to the power of 2 equals 9. Okay, so we need to add this result, b divided by 2 squared. We need to add it to the equation to both sides. So let's write x squared plus 6x plus 9. Yeah, we add 9 to both sides. Plus 9 equals 7 plus 9. Okay, so what do we observe here? We already see a trinomial, and that is the essence of completing the square method, that when we transform it to the trinomial, later we see that this is a common, we can recognize that this is a common algebraic identity. So we will always have a algebraic identity which can be converted to a binomial. So trinomial has to be converted to binomial, and we see it that it is simply x plus 3 squared. This is square of sums. Two sums. Square of sums is called square of sums, and each time we have square of sums, it will be expanded to a trinomial. This binomial will be expanded to trinomial. Because we multiply x, you need to remember this. X plus 3 squared equals x squared plus 2 times x, 2 and 3, 2 times x times 3, so it's 6x, and the last term is 3 squared is 9, and here we just add equals 16, because we added 9 to both sides. So to solve it, you just need to take a square root from both sides, and you will have the solution. So it will be x plus 3 equals 4, because square root 4 is 4. Here is we just, when we square root the binomial, we remove exponent, so we just have only x plus 3 equals 4. And what we need to remember, that x plus on the right, what is on the right side, in completing the square method, this will be, we count this, we solve for x for both 4 on the right side and minus 4. So it will have two solutions. So first let's solve x plus 3 equals 4. So this way x equals 4 minus 3. So x equals 1, or we solve for minus 4. So we say minus 4 plus, not plus, because we move it to the other side. So minus 4 minus 3, x can also equals minus 7. And this is our solution. We solve it by completing the square. Okay, next I will show you how we can convert this standard formula, because this is standard formula. You know, a standard formula of a quadratic equation is ax plus b plus c, right? But we want to have a vertex format. Vertex format is like this: y equals uh, a x minus p squared plus q. So we want to convert this ax plus b plus c, which is here, standard formula, to vertex formula. And I will show you that we can do it much faster by modifying slightly complete the square method. Okay, so I'm going to erase this bottom. We already know the solution. So in order to convert or transform standard formula to vertex formula, we need to stop at this point. Okay, when you stop at this point, this is the point where you can quickly convert it to vertex formula. So let me erase this because we don't need the solution at the moment. Now we're focusing on changing from vertex, from standard to vertex. Okay, so all what you have to do when you stop at this moment, when after converting trinomial to binomial, you should simply write the same what you have here: x plus 3 squared, because we write y for vertex. We always need to y what y equals, just like here we have y, but here we don't have to write this, but we write y equals, so we will write x plus 3 squared in brackets, and here will be minus 16, and that's it. We already have our vertex formula. You see, we need to move this term to the left side. So when we move to the left side, we write minus. And this is the vertex formula. But this is simpler because it's for leading coefficient equals 1. You see there is x on the first, so a equals 1. So if the leading coefficient equals 1, that's how we proceed. It's very easy. It will be a little bit more complex for cases when leading coefficient equals more than that, but it is also workable. So in that case we will just multiply the binomial by the coefficient a, and we'll multiply linear term, this on the right side, will also multiply by coefficient a, and you will have the vertex formula. But now let's verify it. Okay, I calculated from this. You see, I quickly change it to vertex formula. And let's see if traditional method will give me the same result. So I'm gonna change it to vertex formula in a traditional way. So I can erase it. We'll just leave the main formula here. The standard formula will be on top, but I'm going to clean it up. And I will just leave only this, our vertex formula, y equals x plus 3 squared minus 16, and we'll check if traditional way of changing to vertex formula give exactly the same way. Okay, let's go. Let's continue. So we do it a little bit different, not straight away to group this term that we move the linear term to the right side, but we start with writing y. So we can write y equals x squared plus 6x minus 7. So this way we remove 0. We don't have to write 0. What will be next? We will of course take completing the square from middle term from b. So we'll calculate b divided by 2 squared, which was 9. So we'll have to write it again, but there will be something different than before. We'll have to add and minus add and subtract 9 at the same time. So we write x squared plus 6x plus 9 minus 9 minus 7. That's how we do it in this method. We first, this what we calculated, it was b divided by 2 squared, it will equal 9. So from this we need to also write it in the brackets. So this one is this our trinomial, the same trinomial which we had before. So we will write it like this: y equals x plus 3 squared. So we eliminated this, and now minus 9 minus 7 equals 16 altogether. And as you can see, we have exactly the same solution. So we can change from standard form to vertex form by completing the square method and adding and subtracting this middle term. But I think it's a little bit longer. Here we achieve that the same much faster way by simply converting that moment when we had this binomial square of sums. This square of sums can simply be quickly converted by subtracting the term on the right side, and we will have the vertex formula much faster. Okay, so we have solved this for the quite simple case when the leading coefficient equals 1. Right, this is the leading coefficient equals 1, so it was very easy, but now we're going to solve it for a little bit more difficult case. Okay, so I will write this equation here. So this one we need to erase. Okay, let's make it even bigger. Okay, so now our standard formula looks like this: 3x squared plus 12x minus 5 equals 0. Okay, so we see leading coefficient is 3. So completing the square will require a different approach. So in order to do completing the square when we have leading coefficient bigger than 1, we need to divide all the terms ABC by leading coefficient. So what we're gonna have here, we write divide by 3, and also move this constant term minus 5 constant and move it to the right side. So we need to separate the quadratic expressions with the linear expressions. Okay, so after dividing by 3 and moving this term to the right, it will look like this. It will be x squared plus 12 divided by 3 is 4 plus 4x equals, this is 5, because we changed the sign from minus 5 to 5 after moving to the right side. So it will be 5/3. Okay, and this is the moment to isolate b. I mean, to get this completing the square method. So we need to just like we done before, b divided by 2 squared. We need to know what is this. So we have 4b equals 4. So 4 divided by 2, it is 4. So we need to add it to both sides. So we're gonna have x squared plus 4x plus 4 equals 5/3 plus 4. Okay, so again we see this is our perfect square trinomial. Remember that it can have both. It can have both positive signs here, negative. So there can be only two cases in the completing square methods, that it will be either a sum of squares, square of sums, or square of difference. Square of sums or square of difference. Here we see square of sums, which equals to x plus 2 squared. So we see that x plus 2 squared equals 5/3 plus 4. And we will soon have our solution of this by completing the square, but just want to underline that you need to remember, it's very important to know how to transform trinomials to binomials by knowing algebraic identities. So please review what are algebraic identities if you don't know, and you will easily know how to solve it. So how to add 5/3 plus 4? This is for once we need to find the common denominator, because the denominators are different, so we cannot add this fraction. So what is the common, the lowest, least common multiple for this? Of course 12, so it will be not 12. This one will remain unchanged. This one will remain unchanged, but here we need to write 3. So if 1 increased 3 times, 4 also need to increase 3 times, so it will be 12. So it is 17/3. So we see x plus 2 squared equals 17/3. And now you are ready. You are ready to solve it. You just take square root from both sides. So x plus 2 equals 17/3. And remember, you calculate it for both. 17/3 positive and 17/3 negative, because it has to have two solutions as a quadratic equation. So you will solve this simple equation after taking square root. But it's not the main point what I want to do here. So what I want to show you, again, how we can convert quickly this from this binomial to a vertex form. Now I'll quickly show you vertex form. We'll do the same, but this is a little bit more complicated because we have leading coefficient equals 3. So in order to do this, you need to multiply both sides by 3. And subtract this, because you will write y equals 3. Yeah, we times 3, so 3 times x plus 2 squared minus 17. Why did we write it like this? Because here is positive, so we need to move it to this side. It will be negative, and we 17/3 by 3, 3 and 3 cancel out, so we have 17. And this is our vertex formula of this standard formula, and I quickly got it from completing the square method. We stop at this moment when we transform the trinomial into perfect square binomial. Okay, and again with the last, what we're gonna do is we will use traditional method of converting standard formula to vertex formula. I will compare if my new solution is the same, if it works. So let's stop. Yeah, this one, it can be erased. We will only leave this because this is the vertex formula, and I want to make sure that what I'm gonna obtain the same result. So in here we're going to do it differently. Instead of dividing by 3, I will when we change standard format of a quadratic function to vertex format, we need to first factor out these terms, because the leading coefficient is more than 1. So here we have to not divide by 3, but we need to factor it out. So first we write like this: y equals 3x squared plus 12x minus 5. So we will group these terms. This is quadratic terms. We write them in brackets and we leave this linear term. What will be next? We'll factor out 3, because that's what we can do. 3x actually. We'll factor 3x. So y equals 3x times x plus 4, because 3x times 4 is 12. This one we leave alone, untouched. So what should we do next? Now we need to calculate the middle term, and middle term is, one moment, yeah, middle term is 4. Middle term is 4, so we need to do it b divided by 2 squared. It will be 4, so we need to write it like that. Y equals 3x plus 4 plus 4 again and minus 4, and then minus 5, because b divided by 2 squared equals 4. So remember, when we first we factor out from these brackets, and then we divide b divided by 2, and we know that b is 2, because b we divided by 3. We know b is 4, so 4 divided by 2, 2 squared. So we divide this by 3, and then we do b divided by 2 squared. Okay, so what we're gonna get here? Y equals 3x plus 2 sorry, that is too much here. What we factor out, you see it, what we factor out is not just 3, but is x. Yeah, we also need to write here. So 3x x plus 2 squared. So yeah, we see this. This is eliminated. This is this trinomial hidden here. You can see this trinomial. I write it, and then this trinomial is seen here, and we change it. X plus 4 is changed to x plus 2 squared. And there is another point that you see there is 3 before the bracket. So you know that this factor, we multiply everything. So you have to also multiply this 3 times 4. You cannot just write minus 4, but you have to write 3 times minus 4. So it will be minus 12 and minus 5. So remember, you see this from that one, you see this 4. It is in brackets. As long as it is in brackets, it means that you have to multiply all the terms. You see the bracket starts here and finishes here, which means that all these expressions need to be multiplied by 3. But we keep this in the bracket, so we don't have to multiply it, but we move this one outside the bracket, so that's why it has to be multiplied by 3. So we get y equals 3x x plus 2 squared minus 17. And let me get a highlighter. You see, this is exactly the same as what I got here. Y equals 3x plus 2 squared minus 17. So this is our vertex formula. That's how we quickly transform it. I mean, not quickly. It took me a lot of time, actually. It was quite complicated. But if you compare it with the previous method, just rewriting completing square is much faster to get to the vertex form the way I did it previously. Simply divide it by the leading coefficient, later change the trinomial to binomial, and from this binomial multiply binomial by the leading coefficient and move the term from the right to the left side. This is the fastest method, I think, to convert it from what is it called? A standard formula to vertex formula. Okay, so please watch the video carefully and hope you will find it useful. Thank you very much for watching. See you next time.